comes your air, and you will have a fuel line coming from the tank going in here, or yeah, you'll have a fuel line coming from the tank. You'll have a pump in there, diaphragm pump. Anyways, okay, so as the piston moves up this way, you get vacuum here. Air gets sucked in through the carburetor, picks up fuel. The fuel either has oil mixed in it, or you've got oil injected separately. Let's not worry about the oil part for now. Okay, piston's moving up, sucks air through the carburetor, and the crankcase area down here, the area below the piston, gets full of air-fuel mixture. Okay, in the meantime, as the piston moves up, you get a compression event up here. So you got 2 batches of fuel. By the end of this first stroke, you have a fully compressed air-fuel mixture, and you have a fully sucked in batch of air-fuel mixture down here. 2 batches, separate, not connected to each other at all. Okay. Then the piston starts to come back down, because at the top of the stroke, or just before the top of the stroke, the spark plug fires. This is what we want. This is everything we wait for is power stroke. Okay, if we could find a way to make everything else happen, you know, without any issue, that'd be great, because all we really want is power, 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 power. So just before top dead center, spark plug fires, lights the mixture, bang, down goes your spark plug. So as the spark plug lights the spark plug, lights the air fuel mixture. As the piston goes down, you have very high pressure in here. We already know that from 4-stroke. Same thing. You got a big explosion here. Okay, so you got very high pressure in here. Watch this side. Piston's moving this way. Okay, and so all the mixture in here is being compressed into a small space. Now, some sharp-eyed person might say, well, wait a minute, you got a carburetor attached here, you got a little intake manifold or something like that, little tube there. Doesn't all this mixture just go rushing right back out? Good eye. So there is, depending on the design of the engine, there's a couple of different ways that this is done, but the one way is to have a reed valve in here. And a reed valve essentially is like a flapper. Okay, picture it being if you've seen a saloon door that can swing both ways, picture that this is more like a fixed door that can open one way but not, and it can close, but it can't go past the other way. All right, so I'm going to put it right there. And that's a real Mickey Mouse drawing, but I hope you get the point. So if I go back to the intake event for a second here, compression going on up here, intake here because the piston goes up, this becomes low pressure vacuum. Vacuum is, we're talking pressure that's lower than the atmosphere outside, and that's why the air moves to the crankcase in the first place. Remember that areas of high pressure always try to go to areas of low pressure. Remember that whole drinking box analogy, right? You suck on the straw on your little drinking box and the walls of the box collapse in your, you can feel it in your hands, because the air outside your container is trying to go into the container. You created a low pressure system inside the container by sucking on the straw, right? You are the vacuum. You are the intake stroke. You sucked a bunch of juice out and the container walls collapse, and that's because the outside atmospheric air pushes against the container, and the container is a flexible container, so it flexes, and that's what causes the container to actually collapse, and you can feel it in your hands. Okay, so that's what causes the air fuel mixture to come in here. So piston goes this way, sucks in a batch of mixture, spark plug fires, lights the mixture, fires the piston back down, piston goes back down this way. This becomes a compression event back here. This all gets squashed into a small volume, and back to my original point, the mixture does not travel back out where it came from because of this nifty little reed valve. It's a very thin, either plastic or metal or composite fiber flap, and we're talking thin, like you know, feeler gauges that you use for measuring spark plug and ignition gap clearances and stuff like that. Very thin. So it moves on the intake stroke. It moves because it's actually flexible enough that the airflow coming through here shoves it open. Okay, but its natural relaxed position is to slap shut as soon as there's no pressure changes. If the pressure on this side of the crankcase and on this side of the crankcase are equal, then that thing has no pressure acting on it, okay, and it naturally relaxes into a closed position. Now the piston is coming down and compressing this mixture, which basically shoves that, it'll shove that that reed valve closed and, you know, tight, and make sure it doesn't leak. All right. Okay. Here's where it starts to get complicated. Near the bottom of the downward movement of the piston, and I can't go down that far, there will be a port on the side of the cylinder here, and there's more than one of these, by the way, but I'm going to draw just one. And that is an exhaust port. So as the piston gets to here, it reveals this exhaust port. If there's such a thing as a Sharpie eraser, let me know, because I would basically take that out of there. Okay, and your exhaust goes out. Okay, because that port has been revealed. Well, the rest of the whole time it's covered up by the walls of the piston, so nothing can go out there. Piston, you have your spark plug fire, you got a power stroke, you got a power event here, piston's being driven down, air fuel mixture exploding and expanding. All of a sudden you reveal the exhaust stroke, whoosh, out goes the exhaust. Okay, it's not a valve, there's no moving parts, it's a hole, and as soon as the piston reveals it, the mixture goes out. Okay, and around the same time there is a intake runner. I gotta set that aside for a moment. There's an intake runner, and I'm going to put it over here like this, and picture again that this is a port that joins the crankcase to the cylinder, and the only thing that blocks it off is the piston. Okay, so we're going back to the beginning of the stroke here, beginning of stroke 2. Spark plug fires, air fuel mixture is lit, it expands, it drives the piston down, your piston gets to here, exhaust goes rushing out because this exhaust port is revealed, and then and your air fuel mixture is being compressed down here, right? It's under pressure, reed valve's closed. Then the piston gets down a little further. Well, guess what? It reveals this port, okay? And this port goes from the crankcase to the cylinder. It was previously blocked off by the piston, now it's not, and all the mixture down here is under pressure. Well, guess what it wants to do? It wants to go wherever it can go because it's under pressure, right? And so the first opportunity that it gets a chance to go anywhere, it wants to relieve itself. Remember, areas of high pressure want to go to areas of low pressure. This is high pressure. This just became lower pressure because the expanding air fuel mixture that was burning, the power event, it just started going out the exhaust. The pressure in here is dropping, okay, because all the pressure that drove the piston down, it's already kind of done its thing. It's done its job, it's driven the piston all the way down there, and now all of a sudden, boom, out it goes out the exhaust. And so the pressure here is dropping. The further down the piston goes, the higher the pressure down here becomes. So all of a sudden you get into an interesting situation where the crankcase pressure is higher than the cylinder pressure. Well, you go back to that rule. Areas of high pressure always try to go to areas of low pressure. And if they can go, they will go. And so your piston reveals this port, and all of a sudden, all of the pressurized gases down here go running through this little port in the side, and they rush up into the cylinder like that. Okay, that's basically how that works. And now you might be thinking to yourself, doesn't the stuff just go straight across the cylinder and straight out the exhaust? Good thought. And in fact, a little bit of it does, which is why two-stroke engines, they're almost impossible to make them emissions compliant. They're getting better. There's new technology, which I'm not going to explain in a simple basic video like this. But historically, two-stroke engines had very poor emissions because they had a higher amount of unburned air fuel mixture going into the exhaust. Unburned hydrocarbons going out into the exhaust. Okay. So anyways. Alright, so the piston basically made 2 strokes, okay? Let's go right back to the beginning. Let's go to here, and we'll do an upstroke, okay? That's this. And as the piston goes up, you're creating high cylinder pressures, otherwise known as compression. You're creating low crankcase pressures, otherwise known as intake, down here, as the piston goes up, okay? And then, you go from the upstroke to the downstroke, spark plug fires, that causes the downstroke. You have let me move my arm, get out of the shadows, very high cylinder pressures because the air fuel mixture explodes and pushes on the piston, okay? And because the piston is moving towards the crankcase, you have very high crankcase pressure because this is actually a compression stroke for the crankcase. And then you get to the point where the exhaust vents out of the side of the cylinder, and a little further down the way the piston reveals the intake port. This air fuel mixture rushes into the cylinder. And remember that this is a cycle, and we know what cycles are. They're a series of events that repeat. 4-stroke cycle: intake, compression, power, exhaust, intake, compression, power, exhaust. As fast as you can say, I keep going, up to 100, more than 100 times a second when the engine really goes fast. 2-stroke, same thing. Okay, you still have your intake, compression, power, exhaust. It's a cycle. So in this case, we had a piston event go up, we had the piston come back down, which means that the very next thing for it to do is to go back up again. So